A medical domain text enters the system and is sent to the lexical agent. The lexical agent detects 8 possible lexical substitutions. At this point, human-in-the-loop mechanisms could be activated so that users can validate these lexical substitutions. Next, the text goes through pre-analysis. The system detects that the sentence is long and should be split. Punctuation complexity is low, and the percentage of difficult words is moderate. However, the text contains specialized medical vocabulary. There are no numbers, negations, or conditions. The system then generates 3 alternatives in parallel. Generator A is conservative and preserves meaning better. Generator B reorganizes the sentence to make it clearer. Generator C produces a much easier version with short sentences and simple vocabulary. This shows the main trade-off. Candidate A has better semantic fidelity, but lower readability. Candidate C is easier to read, but loses more meaning. So the most readable output is not always the most faithful one. The candidates are then evaluated automatically. The system checks quality and semantic risk using the selected metrics. In this case, all 3 candidates have a meaning BERT score below the 0.80 threshold. This means that there may be a loss of meaning. Therefore, the retry_semantic rule is activated. The router merger agent then decides what to do. Since all candidates present semantic risk, the system selects strategy V2, controlled editing. It uses candidate C as the base because it is clearer and relies on the other candidates to recover semantic fidelity. This avoids free generation and reduces unnecessary changes. This slide shows the retry loop. The candidates are generated again, evaluated again, and edited again. There is some improvement, but the semantic fidelity threshold is still not reached. The number of retries is limited to 2. This prevents an infinite loop. After that, the system can send the case to expert supervision. After all retries have been exhausted, the system does not automatically accept the output. It prefers to reject a readable output rather than accept one that is semantically unsafe. The system detects that the final output is not reliable. Because this is a medical domain text, the risk is higher, so the human-on-the-loop approach is activated. An expert can decide whether the output should be accepted with warnings, corrected manually, or regenerated. The system does not hide the failure. It detects it, records it, and sends it to supervision. This strengthens traceability and safety. Finally, the process includes explicit governance. The system records how many times it fails, how many times it enters retry mode, how many times human supervision is required, and how overall quality evolves. Each failure is logged and can be used to adjust rules, thresholds, prompts, or lexical resources.